So good morning everyone, Assalamualaikum. I review a little bit on spanning, okay. Let V be a vector space. So once I mentioned about vector space, you have to put in mind you have 4 types of vector space, okay, 4 types, which is ulang balik 4 types of vector space. Okay. First one is first one is Rn. Second one is matrices. Third one is polynomial. Okay, and last one is functions. Okay. Now for basis, we will just do these 3. Okay. Still before, in linear combination, we can still do function, but not for basis, but not for spanning, not for linear independence. Okay, just these 3. Alright, so let V be a vector space. I will mean these 3, and S is a subset of V, and we have U1, U2 until UK. Okay, you can use V, you can use U. Then S spans V if for all V in V there exists Ci in R, I from 1 until K, because there is K, such that sometimes I use V, sometimes I use Y. Okay, Y lah ya. Y can be written as a linear combination of all the vectors in S. Okay, kan? Okay, let V be a vector space. Again, I will draw V, a vector space, infinitely many elements. S is a subset, finitely many. Okay, V ni tak terkira, infinitely many. Okay, like R, matrices, polynomials, infinitely many. But S is finite, only K elements in S. Alright, so span S, I put here, span S is actually all linear combination. Okay. Okay. Span S is all linear combination of this, meaning you can multiply U1 with coefficient with any real number, not just integers, and add them up. This is C sub K UK, and the combination becomes span S, bigger. Okay, and since Ci is all real number, this is infinite. Okay, this is infinite, this is infinite, this is infinite, this is finite. Okay, Faham ya? So now S spans V, meaning they are equal if any vector y in V can be written as this linear combination. Okay, meaning you cannot find someone a vector in here because they are equal, meaning this span S is the whole one, is the whole V. Okay, S does not span V if you have one vector in here in V but not in span S. Okay, we have seen this before. So this is the key. This linear combination is the key, and this is why I said this is chapter 2, because this gives you system of linear equation. So this is what we learned for the past two, for the last class. Now, okay. Now for today, I will introduce hari tu kita berhenti page okay. Now go to page 180. Okay, saya ikut dalam buku Just now I use U, in the book I use V. So okay, let S be V1, V2, Vn, okay, a subset of a vector space V as before. Okay, then this set S is linearly dependent, okay, linearly dependent if there exists, C1, C2, Cn, not all zero. This is the key, not all zero, such that, okay, see this, C1 V1 plus C2 V2 plus Cn Vn equal. This is another very important definition, very important thing that you have to know for linearly dependent or independent. You see, before we write linear combination, we equate to the vector y. Now, for this particular section, we always equate to the zero vector. So the zero vector you will know from V will be one of these. So you have to know the zero vector. The zero vector for this R2 will be 0, 0, R3 will be 0, 0, 0, right? For matrices, they're all zeros. Polynomial, the zero matrix for polynomial is the zero polynomial, which is just 0, right? So this is the definition. I will erase the top part. Oops. For linearly independent with the same S equal this, then S is linearly independent if C1 C1 V1 plus C2 V2 plus Cn Vn equal 0 implies all the Ci equals 0. C1 equals C2 equal Cn equal 0. Okay, this one not all 0. If it is not all 0, it's linearly dependent. And if all are 0, it's linearly independent. Okay, this system of linear equation is equal to 0. So note here is system of linear equation is homogeneous. What is homogeneous? Every system of linear equation that equals to 0 is called homogeneous. Alright, so if you look at this page 119, chapter 2, okay, for homogeneous AX equal 0. Mungkin tak nampak sangat dekat sikit. Homogeneous AX equal to 0. Okay, so if you look at page 119, the system is always consistent. Okay, the system is always consistent. So Ci always exists. We just want to know whether it's unique. Unique means 0, right? So when you look at that, unique, it has to be all 0 because it's homogeneous. Okay, or it can be many. So this is a unique solution. And this means many solution. Okay, so this is linearly independent and linearly dependent. Okay, let's look at one example. I will start with number 2, page 182, because I want to start with R. This is actually easier than spanning because it's homogeneous system of linear equation. Okay, page 182. Okay, example 2. Okay, what is the question? Determine whether the set below is linearly dependent or not. Determine whether the set is linearly dependent or not. Okay, you have to read very carefully because sometimes the question asks you whether it's linearly independent or not. Sometimes they ask you linearly dependent or not. So when you write your answer, don't just put yes or no. Just put yes, it is linearly dependent. No, it is not linearly dependent. So if it is not dependent, meaning it's independent. If it is not independent, means it's dependent. Okay, it's the opposite of each other. Okay, S is given as 1, 3, negative 2, 1, 2, 6, negative 4, 2. Okay, if you are not given, what is V? Okay, if you are not given, you know V is R4. Okay, because 4 components. Okay. Alright, so this is your V1, this is your V2, so you will want to find C1 and C2. So this is from definition. You want to find C1 and C2, so C1 V1 plus C2 V2 equal the zero vector of V. Then you will write C1 1, 3, negative 2, 1 plus C2 2, 6, negative 4, 2 equal 0, 0, 0, 0. So what you do is to solve system of linear equation which is homogeneous, right? Okay, so you can multiply out and equate and so on, but we have seen this from chapter 2. You write as column 2, 6, negative 4, 2, okay? And for linearly independent or dependent, it is always 0 at the end. You see the difference between this and spanning? If it's spanning, you will put WXYZ or XYZW, right? So, but for independent or linearly independent, this is always 0 because of the definition. Okay. So, row operation, negative 3 R1 plus R2, 2 R1 plus R3, negative R1 plus R4. Okay. Okay, negative 3 and add, 2 and add, and negative 1 and add. You know this one? You don't have to calculate because it's always 0. Okay? This one is always 0. So what happened here? You will see that many solution. Okay? If you want to solve, you will see, you will get C1 plus 2C2 is 0. C2 is free variable, right? So C1 plus 2K is 0. C1 is negative 2K. From chapter 2, you will write this as negative 2K, K, right? K is in R. Okay, so this means it's many solution. This means not all CI is 0 because you can put, for example, K is 1. Okay, if K is 1, you will get C1 is negative 2, C2 is 1. That is one of the example, the answer. If you plug in here, right? You will get, I erase this, right? Okay, this is just the, you can see this in the notes. Okay. If I replace, I will get 1 times 1, 3, negative 2, 1. Oops, sorry. Negative 2, okay, plus 1 times 2, 6, negative 4, 2, okay, this is equal to, so you still have this equal to 0, 0, 0, 0 without C1 and C2 equal 0. 0, 0 is always one of the solution, that is from chapter 2, 0, 0 is always one of the solution for homogeneous. But we want to see whether there are others. So in this case, this is not linearly independent, or it is linearly dependent, because not all C1, C2 equals 0, right? This is many solution. Many solutions means dependent. Okay, you remember this. So it's quite easy. Okay. This is by using definition. If you think more and you want to do shortcut, that is a shortcut. Okay. Let me show you. I put it in the notes. Okay. I erase this. Okay, I erase this. Okay. So you see, from the question, if you realize S is V1, V2, okay, and you will see that actually V2 is 2V1, okay. Now from here you will see 2V1 minus V2 is 0. So right away you find there is a C1 equals 1, there is a C2, oops, negative 1, and they are not 0. From this one you can put 1/2 here, multiply all by a half, you will get V1 minus half V2 is 0, right? So this is one way. I can accept this also. But this one did not give all solution. Just one solution is enough. That is why I put that in the notes here. But this does not work all the time. You really have to see. Okay. So what's the answer? The answer is yes, the set is linearly dependent. Alright, let's go to example number 2, which is page 180 at example 1. Now this is polynomial. I just put the polynomial inside S. The first one is 1. The second one is t. The third one is 4 minus t. Okay. And V is P1, right? Because the highest order is 1. Okay, so by definition, we will put C1 times 1 plus C2 times t plus C3 4 minus t equals 0. Okay, the 0 polynomial of Pn is just a polynomial 0. This is the 0 polynomial. 0 times t squared plus 0 times t plus 0. Okay. So this is not the number 0. It's a polynomial, which is just 0. Okay. So what we do here is, you remember, if you can multiply out and add and so on. But if you remember last time, we do this, right? So 1 is 1, 0. T is 0, 1. 4 minus t is this, right? And then this is already in row echelon form, right? So this is C1, C2, C3. That's the zero, the leading one in each row. It's okay, this is okay because this is free. Okay, once C3 is a free variable, so many solution. So not all CI is 0. Thus S is linearly dependent. Okay. If the question asks, write out or give some values of C, then you can just get some value from C from here, right? So when you write out, you get C1 plus 4, C3 is 0. C2 minus C3 is 0, right? And C3 is free variable. So you get C1, C2, C3 is equal to negative 4k, k. For example, if C3 is 1, C2 is 1, this is negative 4. So this is one example in which negative 4 plus 4 is 0, t minus t is 0. Okay, so this is linearly dependent. Dependent means they depend on each other. Okay, shortcut. When you look, you really look, this is a combination of these two. So if you multiply this by 4, you multiply this by 1, you multiply this by negative 1, like you already get 0. You multiply by 4 to get rid of this. You multiply by 1. No, minus, right? Okay. Okay. And then this is 0. So already you see that C1, C2, C3 are not all 0. That is shortcut. I can accept this too, but only if you can really see it from the question. Okay, so sometimes you can see the shortcut. Okay. Okay. I'm looking for one example that has matrices. Okay. Okay. Page 188. Exercise 128. try and do. So we will see how many you can done in 10 minutes. Now it's 9:10. When you are done, take the photo and put in WhatsApp. Okay? Okay, who have not liked the video, please like the video so I can see that you are really here. Okay. Nak like ke, nak love ke, jangan gelakkan, jangan nak terkejut, jangan sedih, jangan marah. Ada lagi 5 minit. You don't have to rush and do all. Kita tengok how much you can do, ya. Anybody yang dah siap, any question at all, put it in the WhatsApp. Kalau salah, saya tak tolak markah. Kalau betul, saya boleh fikirkan untuk bagi bonus. Tak ada yang dah siap? So if you use your laptop, you can take photo with your phone and then WhatsApp. But if you use your phone, you cannot take a photo and WhatsApp, right? Wait lah. Because we are doing the exercise and I am checking. Yang tak sempat scan tak apa, you like the video. Later on I will show you again the QR code. If you cannot scan, you can just write in the comment for number where is it just now? Page 188. Okay, you can just write whatever you have because you want to decide whether S is linearly independent or not. So write your answer 1 to 8. Yes means linearly independent. No means it's not linearly independent. You can just write yes or no. Okay. Alright. So, dah. Number 1, S is 1 1 1 2 1 0. Okay. So V is R2 because 2 here, right? So we will write C1 1 1 plus C2 1 2 plus C3 1 0 equal 0 0. Okay. Then one one 1 2 1 0 0 0. Okay. Then negative R1 plus R2. You will get 0 1 negative 1 0. So many solution, meaning not all CI is 0. Thus, S is not linearly independent. The question is, decide whether S is linearly independent or not. So this means dependent. Dependent means not linearly independent, right? You don't have to write what is C because we just need to know whether all CI is 0 or not all CI is 0. So you don't have to write what is the free variables, what is C1, what is C2, okay? Ada nombor 9 ke? Why I don't see number 9? Okay. So, meaning the answer is no. Yeah? Okay, saya padam. Okay, for number 2, Kalau tak sempat salin pun, you can look at the video again, live video, and you can get it from there. Right. Ini yang bestnya boleh ulang tayang. Kelas tak boleh ulang tayang. Kelas biasa. 1 and 1 plus z squared. Okay. Now V is P2. Sebab ada dua, kuasa dua. So V is P2. So you will write C1 times 1 plus C2 1 plus z squared equal 0. Because the zero vector for polynomial is 0. Okay. Then remember we do this. So 1 z squared. Before this we use t or x. So it doesn't matter, I can use z. Okay. So the first one, ni ada P2, so we need 3. So 1 0 0. This one is 1 0 1. And then you have 0 0 0. Okay. So we want to see whether question mark, is this equal 0 or not? If it is equal to 0, then linearly independent. If it is not all 0, then it's not linearly independent. It's linearly dependent. So change row. Oops. Row 2 and row 3. Change. 1 1 0 0 1 0 0 0 0. Okay, so you will see that the rank is, we didn't really see this a lot, but this is very nice. You will see, boleh satu lagi kan? If you do one more time, you will see it's unique. Okay, or you see the rank. The rank of A is 2. The rank of AB is also 2, which is the number of variables, right? There are 2 variables, C1 and C2. Ataupun optional optional, negative row 2 plus row 1. You will also get this. So from here, directly, tak payah guna ni kalau terlupa, directly you can say C1 is 0, C2 is 0. Okay? Yes. S is linearly independent. Okay? Another way to see it is that this is not any multiple of the other one. They are independent of each other. Tapi we cannot just say like this, right? So you have to show this way. Okay, so there is no way that the combination is equal to 0 unless the C1 and C2 equals to 0. Okay, now we go to number 3. Saya sebenarnya nak tunjuk contoh matrix kan, tak sampai-sampai lagi. Okay, we go to number 3. Brian macam mana dapat nombor 9 tu? I'm still curious because I don't see it. S equal 1 0 0 1 0 0 0 0 0 0 0 1. Okay. Okay, so I erase. Okay, what is your V? V equal matrices 2 by 2. Okay, and again we put C1 1 0 0 1 plus C2 0 0 0 0 plus C3 0 0 0 1 equal, what is the zero vector for matrices? It's just zero matrix. Remember that 10 axioms, there has to be a zero vector in the space. So for 2 by 2 is this. Okay? And then we want to know whether C1, C2, C3 equals 0 or not. That's my question mark here. Okay. Try it. Okay, so chapter 2 ya. Kita tulis sebagai laju kan. 1 as column, 1 0 0 1 0 0 0 0 0 0 0 1 0 0 0 0. Okay. Okay. Then just one, negative R1 plus R4. Okay. So 1 0 0 0 0 0 0 0 0 0 0 0 0 0 negative R1 plus 1 0. Okay, one more. Ni tukar ke atas kan? R4 change with R2. 1 0 0 0 0 0 1 0 0 0 0 0 0 0 0 0. Okay, so many solution, right? Many solution, because this is equal to 0, this is equal to 0, but C1, C2, C3, right? C2 is free, right? So not all CI is 0. So no S is linearly dependent. Okay. If you have any question, you can write in the comment. Alright. Okay. Why? What does this mean? So that means if you really want to solve, you will write C1 is 0, right? C3 is 0. And then from this one you get 0 equals 0, 0 equals 0 because C2 is K. It's a free variable. So your C1, C2, C3 is equal to 0, K, 0. K real number. Meaning, you can just put this 0, 0. C2 can be anything. C2 can be anything. So you can put like 2, you can put 3, because this is all 0, right? Whatever you put, this is always 0. So this means, no, it does not mean all C1, C2, C3, 0. The point is, so trick dia ialah, when you are given S, if there is a 0 in the set S, a 0 vector in the set S, S is always dependent. Okay, later on I will give you the theorem, yeah? If there is a set S and there is a 0 vector in the set S, it is always linearly dependent, meaning not linearly independent. Because you can always multiply that 0 vector with a number which is not 0. And the rest you multiply by 0. The rest you multiply by 0, just that particular one, you don't multiply by 0, meaning not all CI is 0. Okay? Nanti saya tuliskan theorem dia, ya. So this is for number 3. Number 3 means no, yeah? Alright, so we go to the next one. 4. Yeah, just one. Okay. Sometimes soalan yang senang tu lebih susah daripada soalan yang susah. Betul. Okay. Alright. If you do this in your handphone, you can screenshot, right? Also, if you do from your laptop, you can also screenshot. Betul? So you can get the notes. Alright, Syakir, got it, yeah? Okay. Now, sama juga, V is R2, right? Because there are 2 components. So you just multiply by C. Okay? Just multiply by C. Because there is only one, tak ada C1, C2, and solve. Tak payahlah pakai matrix. This one you can just solve, right? C equals 0, 0 implies C is 0. So S is linearly independent. Okay, senang. Alright, next. Ayo. Alright, next one. Number 5. 111 112 222. Okay, V is R3. Okay, saya dah penat ni. Okay, shortcut shortcut. You see that ni katalah dia U1, U2, U3, right? Okay, I can see that U3 is 2 U1, betul? Okay, so I rewrite, I will get 2 U1 plus 0 U2 minus 1 U3 equals 0. Betul? So, C1 is 2, C2 is 0, C3 is negative 1. Not all 0. Thus, S is linearly dependent actually, which is not linearly independent. Shortcut, but this is okay because this is what you want to show. Okay, if you want to use, if you don't see this, if you want to use the definition, it's still okay. Okay, ni dengan pemerhatian, just by looking, okay, you can see this. So you can see this is a multiple. So there's also a theorem. If there is a vector which is a multiple or linear combination of the other vectors, then it's linearly dependent. Okay, saya akan bagi theorem nantilah. So there are trik-trik yang kita boleh ikut. Okay, so I will write now, ikut definition ya. Okay, so if you want to write, if you want to write C1 111 plus C2 112 plus C3 222 equal 0 0 0. Okay. Now you will write 111 112 222. If you remember in chapter 2, if you have a matrix 3 by 3, you can also determine the solution by the determinant, kan? That is why when there is a zero matrix, there's a zero vector, there will be a 0 rows or columns, and the determinant is 0. When the determinant is 0, yang 3 diagram tadi, homogeneous, m equals n, then you will have many solution. Itu pun datang dari chapter 2. We see it that way. Okay, so this one, okay, you can do negative R1 plus R2, negative 2R1 plus R3. Panjang sikit, tadi shortcut sangat short kan? You get 0 0 0 0, then you get 0 1 0 0, betul? Okay, one more, R2 with R3. 1 1 2 0 0. So many solution, not all, Ci 0 as is not linearly independent. Okay, because there is a free variable. Okay, there is a free variable. You will see C2 you can equal to 0. You remember when we write earlier? So you see from here also you can see that C2 is equal to 0, right? C1 depend on C3, which is free. Okay. Alright, we move on. Okay. Number 6. Sama je lah ya, number 6. Number 6 is very similar to number 5 or number 2. You can show that it's linearly independent, yeah, number 6. Because you will get 1, 0, 0, 1, negative 1, 0, 1, 0, negative 1. Okay. 1, 0, 0, 1, negative 1, 0, 1, 0, negative 1. So just do this. Selesai kan? Okay. So from here you will see Ci is 0 because this is unique solution. Unique means C3 is 0, C2 is 0, and then you will get C1 is also 0. So instead of that you can also write like this. Okay, so S is linearly independent. Okay, that's quite easy. So you see, if you use chapter 2 and you use matrices, that will be much easier. Okay. 7. Okay, so C1 1, 0, 0, 1 plus C2 1, 0, 0, 0 equal 0, 0, 0. Okay. Trik dia ialah if you have only 2, tadi trik dia ialah if you have a 0 vector, linearly dependent terus. Second trick is if there is one vector which is a multiple of the other one or a linear combination of the others, linearly dependent. They're dependent kan? Third trick is if you have only 2 and one is a combination of the other one, a multiple of the other one, dependent. If there's only 2, they are not multiple, linearly independent. Laju kan? Tapi nanti kita akan lihat theorem tu semula. Tak apa, saya sebut je dulu. So ni bukan multiple ke apa kan? So it's actually linearly independent. But you have to show. So 1, 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0. Okay? Kita nak tengok C1, C2 0 atau tidak? Okay? One more. Just one. Negative R1 plus R4. So you get 1, 1, 0. Oh, yeah. 0, 0, 0, 0, 0, 0. Ni add ya. Negative 1, 0. Then negative. Saya buat 2 kali lah. Saya shortcut je lah. You will get this. Beberapa Beberapa. First, you multiply by -1, then you flip, and then you make this 0. So you get this. So C1 equals C2 equal 0. So S is linearly independent. Okay. Memang kena buat ni Walaupun tadi ada trick, the trick is just to decide whether it's linearly independent or not. It's not the proof, it's not jalan kerja. It's just to see whether the answer is yes or no. Okay. Now last one. Wow, panjangnya. Okay, last one. Saya tak payah salin soalan semula. Okay. There is 4 matrices. Okay. And all matrices, kalau tengok situ tak nampak, tulis sajalah because I want to show you. I saw something. Okay. Dengan pemerhatian, nampak apa-apa tak? You see any multiple, any combination, call it U1, U2, U3, U4. Nampak tak? Dan siapa-siapa nampak, cuba type. Ada combination ke apa ke? Sama row. Determinant apa yang 0? Mana ada determinant? You cannot find determinant. Determinant only for n by n matrix. This is not n by n. Okay. Sama row, mana ada sama row? No, you have to look all these 3, 4 vectors. Any of them ada multiple? Tak kan? Not multiple, right? But you can see, nampak tak? U1 is actually U2 plus U3. Betul tak? So from this, rewrite, so U1 minus U2 plus U3, tak ada tak apa. Betul? Betul? Okay. Okay, so from here, you want to compare with the definition of linearly independent, kan? Right? This is the definition of linearly independent. You want to know whether all CI is 0 or not. From here, you can compare. You will say that C1 is 1, C2 is -1, C3 is 1, C4 is 0. So, not all CI is 0. So, S is soalan dia linearly independent, kan? S is not linearly independent. Ni shortcut. Kalau nampak, kalau tak nampak, buat cara panjang lah. Clear? I will do the long way. So giving this definition, katalah kita tak nampak. So what we have to do is, ni lah kan, macam chapter 2 tu, tapi panjang lah. 1, 2, 3, 0, 0, 1. Okay. 1, 2, 0, 0, 0, 1. 0, 0, 3, 0, 0, 0. 1, 1, 1, 1, 1, 1. 0, 0, 0, 0, 0, 0. Panjang kan? But you can save all this by the shortcut. Tapi kalau tak nampak, if it is not too obvious, this is what you have to do. To solve for C1, C2, C3. Dah nak pukul 10. Sekejap je, okay? We are almost done. So, negative 2 R1 plus R2, negative 3 R1 plus R3. Oh, kita start 8.5, lupa, okay? And then, negative R1 plus R1, 2, 3, 4, 5, 6. Dr. Ibrahim ada tak? Tak nampak Dr. Ibrahim, are you here? Okay. So 1, 1, 0. Okay. Negative 2 and add. Okay. Negative 3 and add. 0. Negative 3. 3. 0. Yang hujung sentiasa 0, tak payah kira. Okay. Negative 3 and add. Okay, and then this one is just 0. This one is just 0. Last one sama dengan first one. Okay. Okay, maybe 2 more. Diri lah. Okay. Yang ni saya terus bawa ke bawah and then I bring this up. So 3 row 1 plus row 3, tapi saya buat kedua So 0 ni tak boleh. Sorry. I cannot do that. Sorry. Okay, this one is negative 1 over 3 Yang row 3 tu, lepas tu saya ubah dengan row 2 terus. So 0, 1, negative 1, 0. Multiply by 1/3. Okay, 0, 1, negative 1, 0, and then I bring. So the rest just 0. Okay. And then from here, you can see many solution kan? Because the rank of this is 2. The rank of this is 2. But unknowns ada 3 kan? Okay. So if you compare the rank of A is rank of AB, but is less than 3. Which is equal to 2, right? The rank is 2, less than the number of unknowns, so it's many solution. Many solution. Or you can say that C3 is free. You can also say that C3 is free variable. So when there is a free variable, then there are many solution. So you will say not all Ci is 0. So if not all Ci is 0, you back to here, S is not linearly independent. Okay, long way compared to short way, kan? Alright. So I think this is pretty clear. Clear kan? Okay. Okay. Let me go back. Now you can, when you go back, you have to go through all the examples. Okay. You have to go through all the examples. I will go through two things, okay? If you remember, for spanning, kita ada theorem tu kan? Okay, S, dan kita ada U1, U2, U, apa kita pakai M okay, and then V is Rn kan, okay. The first one, if M is less than N, then S does not span V. Ingat tak? Right? Okay. Contoh lah kan. Kita ada 1, 2, 1, 1, 1, 1. This is R3. 2. This is 3. So S does not span R3. Tapi kena bukti lah secara guna definition. This is just to see kan. Yang kedua, if M equals N, then kita bagi dua kan. If A is not 0, then S spans V. If the determinant is 0, then S does not span V. Okay, contohnya tambah lagi satu. If I add another one, you can check that the determinant is not 0. So this actually M ada 3 equal to N 3, and when you calculate the determinant, it is not 0. Okay, so in this case it span R3. Tapi kena tunjuk jalan kerja. The second one, if I change this to, contohnya when you write the determinant, okay, at the row yang sama kan, so the determinant is 0. So this one, by this one, does not span. Okay. Again, kena write out what it means by spanning. You have to find the C, exist or not. You have to relate. Kalau guna determinant, you have to relate from chapter 2. Determinant not equal to 0, meaning unique solution, meaning Ci exists, so it span. Cerita tu ada markah. You cannot just say determinant is not 0, so span. Nah, contoh macam tu lah. Okay. Now, oops, miss spanning Now, page 183. Okay. If M is bigger than N, then S is not linearly independent. Kenapa saya nak guna panjang-panjang not linearly independent? Because later on, there is a definition of a basis. A basis is when it spans V and linearly independent. That is why we always want to use the word linearly independent. Okay, so if you go back to our examples earlier, cari yang M bigger than N, then all those examples you will see that they are linearly dependent. Okay, and for the second one, if M is N, then again A ni datang dari mana? A ni yang saya sebut hari tu, you write U1, U2 as column kan? Itu A dia lah. Okay, then if A is not 0, then S is linearly independent. Because when the determinant is not 0, remember the tree diagram, you have a unique solution. Unique solution for homogeneous means all CI is 0. All CI is 0 means linearly independent. If A is 0, then S is not linearly independent. So dapat soalan je, kita dah boleh agak jawapan lah. Okay, and then how do you write it out? And you realize later on, when we're talking about basis, that is this Thursday in my next class, you will see that by calculating the spanning, which is equal to the Y, you can easily get the answer for linearly independent. Because by the calculation of this, Y you just equate all to 0, you will get the answer for the second one. Okay, alright, so this is the theorem. And now go to page 188. Okay, page 188. S is linearly dependent or not linearly independent if it satisfies any of this. Consists of a zero vector. Because I mentioned earlier that if you have U1, U2, somehow you have a zero vector here, and then probably you have UK until UM. If you have a zero vector here, everything else you multiply by 0, this one you multiply by a number, then you will get still all equal to 0. Okay, so not CI equals 0, because the C that you multiply with the zero vector can be any number. Okay, 3 darab kosong pun dah 0, right? The second one, consists 2 or more vectors which is a multiple of each other. Consists of a vector or more consists of vectors that are multiple of each other. Like this. If you have S is say U1, then U2, maybe you get UK, and somehow you have T of UK here, then you have UN. A multiple. a multiple means you just let this multiply by 0, by 0, by 0, by 0. Oops. Because call this TUS, right? Okay. So if US is TUK, okay, you will write TUK minus US is 0. If it's a multiple, and then just let 0 times U1, 0 times U2, okay, plus 1 times T times UK plus, and then you have minus US, and then the rest you multiply by 0 equals 0. Since this is equal to 0, right? The rest is equal to 0 is 0, but this C is not 0. Okay, you go back to the previous example that we have, and you will see this. For example, like you have 1 1 1 2, oh tak boleh, 1 1 1 1 1 2 2 2 4. Contoh okay, so you see this one is a multiple, right? This one is a multiple. So if you call it U1, U2, U3, so U3 is 2 U2. Macam ni tadilah kan? Then you bring to the other side, you get 2 U2 minus U3 is 0. Macam ni lah kan? And then you want to compare C1 U1 plus C2 U2 plus C3 U3 equals 0. This is the definition of linearly independence. There is missing U1, kan? So U1 tak kena mengena, you just multiply this by 0, and then you will put this is already 0 because they are multiple. Terus dapat kan? Compare these two, you will see C1 is 0, C2 is 2, C3 is negative 1. Not all CI is 0. So ni proof sebenarnya. I think in the exercise later ada proof, something that you have to prove, yeah. So this is why if you have one multiple yang kita buat tadi, then you already can get the coefficient. Okay, saya nak explain je lah maksud dia. And then the third one is yang kita buat juga tadi, ada linear combination kan. One or more vectors is a linear combination. Okay, consists of vector or vectors that is or are linear combination of the others. Okay, ini susah sikit sebab kadang-kadang dia tak jelas, especially if linear combination kan macam ni. You have, let's say, U1, U2 until UM kan. Okay, and then you want to find C1 U1 plus C2 U2 plus CM UM equals 0. Linear combination bermaksud some of the UK is like D1 kan, kita tak tahu U mana, so K yang mana, so I just put contoh lah, mungkin one of the use is linear combination of the other two. Contoh, kalau ni 0, it goes back to multiple, tapi dia mungkin linear combination. So from those linear combination, kita dah dapat the non-zero CI. It's more little bit theoretical. If we stick to the definition of linearly independent, you don't really have to think about this. Okay, this is to do some shortcut. Okay. Ada tak soalan dari semalam saya bagi exercise 23 tu kan? You have any question? 23 tu? 23? Dah ada jawapan belum? Okay. Page. Saya bagi hint sikit ya. Cepat buat tak ni? Saya bagi in the last class. Okay, this one does not span part 2. One is because the determinant is 0. Okay, because m equals to n, but that's not the answer. So S spans R2 if there exists C1, C2 in R such that C1 10 plus C2 00 equal XY. This is for all XY in area 2. Okay, so jalan kerjanya seperti ini, right? And you can easily see that the system is inconsistent. Thus, CI does not exist. So S does not span R2. Alright. For B, it's very similar. For B, this is for A. For B, you have to write again. Don't just write this, because what does this mean? So you have to write S span this if this is this, C1 11, C2 181, XY, and you can mention that this system is consistent, right? Because the determinant is not 0, it's -2, C1, C2 exists, so it span. Okay, these are the wordings that you have to write. Okay, don't just jump like determinant is not 0, span. No, you have to know why. Okay, the same thing for number 21, because I give you m equals n equals 3, so you can find also using determinant. If the determinant is 0, the system is the CI does not exist and does not span, right? Because the system will be inconsistent. For 22, if S given as 4 vectors, okay, is 3630 in span? You don't have to find the span. The question says This means, can you write this as a linear combination of the vectors in S? Okay, can you find C1, C2, C3, C4 that you can write 3, 6, 3, 0 in the span? Okay. Number 23 also, determine whether the set below spans R, R2. Okay. Number 1, you can see the determinant is not 0, so it's span. Part B, although you have more m bigger than n, you can do this and you'll see it's consistent, so it's span. C, it does not span because m is less than n, but you have to show using this, the system is inconsistent. D, yes, it span. Okay, because you have more vectors, you can get rid of 2, 2 because it's just a multiple of 1, 1. After getting rid of 2, 2, you have 1, 1, 1, 3. And you see this already span R2, but you write out like this, you can see it. The last one, I can see it from here. Okay, the determinant is not 0. Kan ambil ni negative 2, so this one, yes, is span. Okay, and then you can start now number 24. Until (36). Don't have to hand in, yeah. This is just exercise. Just try and do if you have problems or not. Because before I introduce the next section, which is basis, you have to understand spanning and linearly independent. Okay, because basis is just combination of these two. So try to do this, especially number 33. I mentioned earlier that we don't do function, okay? We don't do function for basis, but we can do linear combination with function. Okay, let me give you one example, yeah? Decide whether S is cosine squared x, sine squared x, 2 is linearly independent or not. Okay, when I mentioned that normally for basis we don't have function, but for linearly independent we can have a question on function or linear combination. Maybe you've seen it before, or maybe in the last assignment before. Like, can aku tak ingat soalan dia. Sekejap, thought I saw one example. Yeah. This one. You might have seen this in this example as an exercise, kan? Okay, this one. Decide whether y is cosine 2x is a linear combination of vectors in S where S equal 1 sine squared cosine squared. Right, this is page 160. So you have to remember the trigonometry identities. Ingat tak? Trigonometry. Sine squared plus cosine squared is 1, kan? Okay. Cosine 2x is 2 cosine squared x minus 1. Betul? Sine 2x is 1 minus 2 sine squared x. Okay? So, remembering this, so cosine 2x ni kan? So 1 times 1 plus 0 times sine squared x minus 2 cosine squared x. Oops, silap. Minus. Okay, so ni contoh ya. A linear combination in terms of using trigonometric identities. Okay, so for this question, to decide whether it's linearly independent or not, the answer is yes, because this is a linear combination of these two, kan? Because I know cosine squared x plus sine squared x is 1. Multiply all by 2. 2 cosine squared x plus 2 sine squared x is 2. So combine semua, kita dapat 2 cosine squared x plus 2 sine squared x minus 1 times 2 is 0, kan? So C1, C2, C3 is not 0, such that the linear combination is 0. So the answer will be no, it is not linearly independent. So tu tadi yang saya kata, try this one. So you have to also do this. Yeah? This is very, ni soalan ni daripada soalan final dulu sekali. Okay, so this is it. Do this exercise and do also the physical exercise math aja. You have to be fit, you have to be healthy. Jangan malas-malas, baring tidur makan je. Do some exercise. Dapatkan at least 3, 4, 5 ribu steps a day, if not 10,000. Alright? Okay, so now siapa yang tak sempat ambil attendance tadi, to the rest, to the others, bye, take care, stay at home, stay safe. Yang tak sempat tadi saya bagi attendance mula ya. Alright guys. Bye. Oops. Formula salah. Oh, okay. Okay. This is equal, betul. Okay. Right. Okay, these two are equal, yeah? Thank you. Okay tak tu? Okay. So kena ingat jugalah calculus 1 for linear algebra. Okay, bye.